And hey, yeah, brilliant. So, as I said, these are words that we use in everyday life, but they mean different things. And we are trying to get used to one, using them, and two, what they mean. And it takes time. Okay. So, before I go through everything, all the words I'm going to use, I'm going to tell you today is all about drawing. And it's about drawing arrows and a little bit of adding and taking away. That's it. That's literally all it is. Okay. So, first part. Now, that sounds easy, but it's really not that easy because you get really confused. We have done scalars and vectors, but doesn't matter if you've done them before. Doesn't matter if this is the first time you're doing them. You forget. So I'm going to go through them all again. Okie dokie. What is a scalar? Well, it says this weird thing, a quantity that has magnitude, size only. It means it just gives you a number. So if we look at speed, it would say, oh, I'm moving at 10 meters per second. It's just told you how fast you're going. That's it. And this would be speed. This is a scalar quantity. And this is where you've got to get used to words. There'll be no positive, there'll be no negative, there'll be no direction. Now, a vector gives you magnitude and direction. So if we knew the direction in which we're moving, it would no longer be speed. Let's put this is an example of a scalar. Okay. So speed is a scalar because you only know how fast you're going. That's it. Now, if I turn around and I said, we're going in a given direction, we're going to say, I'm going 10 meters per second, I'm going to draw it. I'm going 10 meters per second to my right. I've just given you a direction. I've drawn an arrow. So, if you can draw an arrow, it's a vector. Okay. So, this is no longer speed. This is now a vector quantity, and the type it is velocity. So velocity, we know which direction we're going in. In this case, generally speaking, this is a positive number. If it's a positive number, you're moving to the right. If I said, dude, you know what, I'm moving, I have a velocity of minus 10 meters per second, I can draw that. I will draw anything as a ball, easy to draw a circle, and I will be moving to the left at 10 meters per second. My speed is 10 meters per second. My direction is to the left. So my velocity will be minus 10 meters per second. Right. Okie dokie. So we're drawing. Now, what we're going to look at today, right, is a resultant force or forces. Forces as vectors. Now that sounds really, really, really tough. But we're going to have a look at my bike. I will draw my bicycle as a circle. Now, I got stuck mountain biking on a mountain and I had to push my bike this direction. Now, you see, I've drawn an arrow. Force, the unit of force is newtons after Sir Isaac Newton. Let's say the force is 10 newtons. So I had to push my bike to the right with a force of 10 newtons. So because I've drawn an arrow, because I can draw an arrow, this is a vector. Okay? So force is a vector. A vector. Okay. All right. Force of vectors move to the right. Brilliant. Force is a vector. Love it. So what's a resultant force? Let's have a look at resultant force. All right. So it was really funny. I was pulling a trailer with my husky. This is my trailer. I was pulling it uphill. Me and my I'm teaching is a new husky, is a young husky, so I'm teaching him how to pull. So let's assume I was pulling with 100 newtons. My young husky decided, I wonder what that is, and turned around and went the other way with a force of 50 newtons. Well, no, let's make it 20 newtons. All right. Now, two things. Let's just get rid of that. My arrow shows the size. So arrow shows two things. The arrow shows direction and the size of the force. Not exactly, you don't have to be exact. Sometimes you do, but not you won't have to for a long time. So arrow shows the direction of the force, which means which way am I pulling? Or my husky's pulling, which way am I pulling? And you show it with an arrow. And the arrowhead tells me, the arrowhead shows me the direction. The length of the arrow shows me wow, excuse me. The length of the arrow, oh my lord, that was a really bad sneeze. The length of the arrow shows me the size of the force. So as you can see, I'm pushing forward. Well, I was actually pulling. We both had harnesses. I'm pulling to the right with 100 newtons of force. Newt, being a naughty boy, was pulling to the left with 20 newtons of force. So what's the resultant force? Okay, so the way you work it out is, to my right is positive, to my left is negative. So the resultant force is, really simply, 100 newtons minus 20 newtons. Oh dear, there should be big ends. So Isaac Newton will be turning in his grave. With a resultant force of 80 newtons. So you just do 100 minus 20, they're in opposite directions. The resultant force is the overall force. Okay, now, equilibrium, all right, is when, let me write that here, equilibrium. Oh, do you know what? I might do that as a sticky note. Equilibrium, all right, is when the resultant force is 0. Okay, so I'm going to give you the easy version first, all right? The easy version is, let me just change that typing out. All right, so if you think about it, as Newt gets bigger, Newt is our youngest husky. If I'm pulling with 100 newtons and Newt sees a rabbit, I am in so much trouble. He decides to go that way at 100 newtons. He's going the opposite direction. My resultant force is 100 newtons minus 100 newtons equals 0 newtons. Now, we can turn around and in this case, we say, right, we're not moving. However, to be exact, today I don't mind if you're exact, there is no change in speed. Okay. No change in speed. Okay. Now, all this is two things. Recall definitions, going through the words. All the information is here in terms of the words. These are key words that you need to learn. Now, and again, it doesn't matter if you get it wrong. It's you start hearing my voice using these words. All right? And then after a while, you just think, I've heard that one before. and you'll stop thinking about it as being complex. That is the point of this. The second one, here, the mediums, this is where you've got to draw. All right, so I'm going to show you number 11, just over here. A car has a, car, I'm going to draw a car. I draw a car as a circle. Look how easy that is. There's a forward driving force, forward, 500 newtons. And a backwards force, a drag force of 200 newtons. See, that's your drawing. That's negative because it's moving to the left. So my resultant force, my resultant force equals 500 newtons minus 200 newtons. That gives me 300 newtons. Okay. So I hope that makes sense. And all I'm going to say is, I've spent 10 minutes on this.